So we are looking at state of matter, and we are going to base on the amazing world of matter and its different forms. So let's look at what we will be doing for today. Today we'll be looking at the matter itself. When we say matter, what is actually matter? And then what is the states of matter? And the solid, we look at solid, we look at liquid, and then we look at gases. Then, so what is everything around us? What is everything around us? Everything around you, from the air you breathe to your school decks you often interact or sit on, are all made up of matter. Matter is anything that take up a space and has mass. So I am also matter because I have mass. I also take up a space, so I'm considered as matter. This one too is considered as matter. Why? Because it occupies space and it also has mass. This one also happens to be matter. It occupies space. It also has mass. And the last one, which is a hairbrush here, occupies space and has mass. And even my marker here has mass and can occupy space, so it is termed as matter. Now if you look at the diagram very well, we have three diagrams there. We have solid, liquid, and that of gas, and I and you have seen some before, but today we are going to explore deeply what is inside. Alright, come over here, little boy. So this is what we are going to do. Defining matter. Matter is anything that has mass and take up a space. Now think of it as stuff all around you, from your decks to the air you breathe. Everything is made up of matter. It is the basic building block of our universe. Everything you see around us is termed as matter, regardless of what you can feel. They are all termed as matter. Okay, so what are types of matter? We have materials. We often talk about materials, but materials are these types of matter. They are the types of matter we use. Example is the wood, the plastics, metals. They are the common materials we often use each day in our life. Now, each has a unique property and uses. Now, think about objects around you. Any object around you, just think about it. They are termed to be matter. Why? Because they have the capability to change from one form to the other. So if you look at the diagram very well, let me bring it a bit closer to you. Now you can tell that we have two materials there. I think you can see candle. I can also see orange. I can see ice cubes in water, and I can see straw. I can also see glass of water, and then some ice. They are all matter. Water and ice liquid versus candle solid, illustrating the state. So we have water and then the ice, the water being solid, the water being liquid rather, then versus the candle, which is solid in nature, but when it is melting, it produces gas. At the same time, it also becomes watery at a certain state. When the heat is still there, it still become liquid, and then when it then cools, it solidifies, or it becomes hard. Look around. Everything you see and touch is made up of matter. So we have some stuffs here, from the water you drink to the clothing you wear. Matter is everywhere. Whatever we talk about is matter. Whatever we talk about is actually matter. To the bread you eat. So we have a cup of water and that of ice inside, yeah, matter. Then this one, the balloon, the halogen balloon, then that of bread, or is it cake, whatever. So we are all made up of matter. All right, why you should study matter? Why important to understand that everything around you or around us, from the water we drink to the air you breathe, and even your phone, is made up of matter. And how knowing if different states or solid, liquid, gas helps us to make sense of our world. This is the reason why we should study matter, the importance of the things around us, including the water we drink, the air we breathe. Whatever that you have in possession is made up of matter. Now let's look at the overview of these three states. We have the solid, the liquid, and that of the gas state, and each of it has their unique properties that help us to arrive at a certain point. Now, these particles in motion. Imagine tiny building blocks in solid. Particles are tightly packed and they vibrate in place. Liquid have particles that are close but can slide past each other. Gases have widely spaced particles that move freely and quickly. This movement explains why solid keeps their shape and liquid flows and gas spread out. We are asked in any way why solids are often hard and they keep their shape. It is as a result of how their particles are closely packed and they vibrate at a place. That is the reason why solids are closely packed. What of liquid? The liquid have particles that are close but can slide past each other. So they have that sliding effects, and that's why they flow. Then gases have widely spaced particles that move freely, and that's why when you have gas in possession, around you, it moves fast within a short possible time. You don't see it any longer, then it goes away. All right, now solid, in terms of shape and volume. When you take solid, what happens? Imagine you have an ice cube in your hand. What happens if you try to squeeze it? Does its shape change easily? I'm giving you just 2 seconds to be thinking about it. All right, so I think you have arrived at the answer. How it stays mostly the same. Why do you think solid, like that of ice cube, hold their shape and take up a specific amount of space? Now, this is as a result of the shape that it has. Let's see. Now, the solid particles arrangement. In solid, particles are tightly packed in fixed and orderly positions. They vibrate but can't move freely. These close arrangement give this solid their definite shape and that of volume, like an ice cube. So ice cube, I'll be using an ice cube here for much of my examples. So that is how it works. Little boy, come here. Alright, so solid around us. Look around. Solid are everywhere, holding their shape and volume. They think about your decks, think about the rock, and even your school building. Now, without your school building not being solid, you wouldn't be able to see that structure in there, holding itself together for you to get shelter and then peace of mind to learn. So, and also the materials in there that can be touched easily, that can hold something, or that can be held easily. They have their shape and they have their volume, and that's why they are called solid. They are solid because the particles are closely tied together and they hold themselves together. Now, can solid change? I you know liquid can freeze and then boil, right? Now, gases can also condense. But what about solid? Can a solid object like an ice cube or metal spoon truly change its form or state without just breaking apart? What do you think might cause such a change? Can you think about it within just 5 seconds? Okay, I hope by now you have come out with the answer. So let's move to the next. Now we have what you call crystalline solid, and we have the amorphous solid. Now let's look at the crystalline. Solid. Imagine building with Legos. Solid have particles arranged in very organized, repeating pattern. Think of salt or diamond. This matter has a neat structure which gives them sharp melting point and predictable shape, and that's why they are termed to be crystalline solid. What of the amorphous solid? The amorphous, little boy here. The amorphous solid. Now imagine a pile of sand, or you pile sand together. Solid have particles jumbled together without a regular pattern. If you have the sand jumbled together, you see that everything is everywhere. It doesn't have pattern for you to trace to get the line of which each part is going. Now, example include glass and plastic. They soften gradually when heated and break unpredictably. And that's the reason why these particles break easily, and also they soften easily when they are heated. They are heated because, or they change their shape because their patterns are not regular. You don't have a regular pattern, and the particles are jumbled together, so you can easily break it down without any much stress. Unlike gold and that of salt, because of its crystalline neat repeating pattern, it's make it very difficult for you to break it in as much as this stuff is concerned. Now, liquid. The liquid we use, liquid like water and juice flow freely and take the shape of their container. They are all around us. Now, how many of us haven't seen liquid before? In one way or the other, we've all seen liquid before, and we can't dispute the fact that liquid can flow. Now, why is it that they can flow freely and they also take the shape of their container? Can liquid be compressed? These are some of the questions you should be asking yourself. Yeah, we know solids are hard to compress and gases are very easy. What about liquids? Trying to put everything together for it to become one, pushing everything for it to go to one place. For liquid, it's way more difficult. Imagine trying to squeeze a water balloon or a syringe full of water with no air bubbles. Yeah, you see the bubbles there. Do you think the particles in a liquid can be pushed much closer together? Why or why not? Can I get your answer in the comment? Do you think the particles in liquid can be pushed much closer together? Why and why not? Now, gases. This is the state of which we cannot see with our naked eye, yet we feel it. We often have experience with it. So far, imagine air filling a balloon or a room. Gases have no fixed shape, neither volume. So gases, this is what they do not have. They have no shape, they have no volume. They spread out to fill any space they are in. Their particles are far apart and they move freely, making gases easy to compress. So the reason why gases are easily compressed is as a result of the particles. And I think you are seeing the particles. The particles are widely spread out for you to see whatever that is happening. They move freely. They are not stable. They move freely with no much hesitation, and that is why we are able to compress this stuff. Okay? All right. Gas particles arrangement. In a gas, particles are super spread out and zoom around freely. So we can see a gas molecule moving around randomly and quickly, filling any space. So in your room, gas is there. In your stomach, gas is there. The oxygen you breathe, your blood contains this gases and all that. They move randomly and quickly, filling up any space they are in. That's clear. That's why you feel change of temperature or air wherever you find yourself. This is why gases do not have fixed shape and volume. So if you are asking anyway why gases do not have fixed shape and volume, it is as a result of the random and quickly movement of gases, and they able to fill up any space. Alright, gases are everywhere, even if you can't see them. Air is a mixture of gases and we breathe every day. So a clear example is the steam you are seeing, your cloud. The atmosphere, it consists of the gases, different nitrogen, carbon dioxide, oxygen, and all that mixed together. Now these gases, we can't always see these gases live. The air we breathe, we can't see. Who has ever seen the air he or she breathe? No one has ever seen that, but we know that they are there. How do you know that gases exist and take up a space even when they seem invisible? Think about balloon, wind, even how smells travel. Think about it. Now, gas compression and expansion. A lot of space between gas particles. The reason why gases can be compressed, and I think I've made this submission. The reason why gases can be compressed and also expand is it has a lot of space between its particles, and gases can be squeezed. You can squeeze the gases. It is as a result of the nature of the particles of gases. Then gases can also spread out, or it can expand easily. Now think of bicycle pump. What happened? Or the ball pump. What happened? Because gases has the capability to fill in a space. Anytime you push in that energy, it then push all the gas into one point and then it inflates your ball and then make it very hard for you to play. All right. I think my little boy will come in that this one will be. So let's look at the properties of each of these in a tabular form. So we have solid, liquid, and that of gas. In terms of shape, solid has definite shape and it holds its own shape. That's okay. They are definite. So solid has definite shape. Liquid has indefinite shape. They take a shape of their container. Gases also have indefinite shape. They take the shape of their container. In terms of volume, solid has definite volume. Liquid has a definite volume. We can measure the volume of solid, also measure the volume of liquid. What of the volume of gas? They are indefinite. They fills available space, so they are indefinite. What of the particles arrangement? In my earlier submission, I said that solid particles are tightly packed and they are orderly. That's why we looked at the crystalline and the amorphous. The one that is not orderly arranged are easily to break down or melt easily. But the crystalline one, it is way more difficult for you to break the bond that exists between them or the particles. Now, the liquid, it's close together and they are random. What of the gas? The gas, they are far apart and they are also random. Now, let's look at particles movement. When you talk of solid, they vibrate in fixed position. A liquid has, they slide past each other. Liquid do slide past each other. Then, in terms of gas move freely and rapidly. Now, compressibility. The compressibility, very difficult to compress. If you look at solid. Now, a clear example is this guy. Try as much as possible to press it for it to become, it's still the same. You can see it very well. It's still the same. Yet I have pressed it, but it's still the same. Why is it still the same? Because the particles are closely packed together and they are very difficult to compress. Now, water too is very difficult to compress. If you get your water and then you are pressing it in your palm or something like that, you see it will splash and then move out. It is as a result of the particle, the nature of the particle that slide over each other. Then easy to compress, that of gas. Gas has their particles moving randomly, so it is easy to collect, then bring it back to its normal space. Now let's look at examples. This one can list thousands of examples for me. We have, if you come to the solid, we have your ice, we have your rock, we have your desk. When we come to the liquid too, we have your water, we have your juice, we have your oil. Now, anytime we talk of liquid, most people attention often shift to water, but water is an example of liquid. Then gases, we have air, we have your steam, we have helium, and all that. They are all gases. These are the key takeaways. Matter has mass and take up the space. Solid have fixed shape and volume. Liquid have fixed volume but no fixed shape. And gases have no fixed shape or volume. Particles arrangement determine its state. So today, if you haven't learned anything, it is these 5 things that you should put in your mind, that as you interact with the staff around. Know very well that Matter is everywhere. From the air you breathe to the phone in your hand, everything around us is made up of matter. In its different states, you have solid, liquid, and that of gas. Now you are supposed to keep observing the world, and you will see the matter constantly changing and interacting. So today, what have you learned? Today, what have you learned? Kindly share it in the description below. Let me know what you have learned today about the stuff in relation to matter. So, whatever being the case, see you in our next session.